nothing exploded, so we'll start with the tutorial. Okay. I'll start with the first one, the tutorial 0. It's about installing Python and Python in general. First, how many of you have used Python?
Well, I never use Python.
I don't have any experience with Python actually.
Any experience?
Use it to print hello world.
Okay, so
Never use it.
okay, so there's a lot of people that haven't used Python at all, or I guess there's people that haven't used any programming language, right? Some of you don't. Sorry. Have you ever programmed at all? Have you ever programmed?
No.
No?
No,
Okay.
personally not experience.
No experience then. Okay. That's good because this will be very basic. At first, what's the difference between Python and other programming languages? The difference is that Python is a high-level programming language. That means that there's a lot of abstraction in the language itself, and it's easier to learn and to type than other programming languages. A funny thing is that the name Python is based on the TV show Monty Python, English TV show, and that's why it's called that way. Well, if you have a Mac OS or Linux, you already have Python installed by default because some parts of the operating system works with Python. If you have a Windows, you need to install it in that page. That's the official way to download Python. And after that, you can install the IPython notebooks or Jupyter notebooks with this command, pip install IPython. As we don't want to break the operating system, it's not that good to start tweaking the default Python. Usually it's better to create an external environment with a packed version of Python. And that's why we try to install it with unofficial distributions as Anaconda or Canopy. Especially Anaconda is very easy to install. You just download and double click, and it will create an environment of Python, so you could not possibly break your operating system by deleting some packages or something like that. And it has already 300 Python packages, the most common ones, already installed, so you basically don't need to install anything. And for the purpose of this course, you just download Anaconda and that's it. For the tutorials, you did not need to download anything because we are using Google Colab, that is an online tool that has Python already, and we can use it only with the web browser. About Jupyter notebooks that we'll be using them, as you can see, the logo is Jupiter, the planet, with the moons, and Jupiter is written with a Y instead of an I, and that's a wordplay because Jupiter here means Julia, Python, and R. That are the 3 core programming languages that Jupiter supports. And it's also a homage of Galileo's notebooks of the discovery of the moons of Jupiter. If you don't know who Galileo is this guy, okay? And the original Jupyter notebook is something like this. As you can see, here you have text explaining something and then a figure. In this figure, we can see the little stars here that are the moons of Jupiter, the big circle, and you can see that in between figures or code in our example or our case, you can explain what you're doing, and that's the main spirit about the Jupyter notebooks. So basically you have two types or three types of cell in the Jupyter notebook. One that is a markdown cell in which you can write something, a code cell in which you can program, and you can also do a code cell that is interactive. I will be showing those. For example, here you have a cell. I can click it. It has a title, a subtitle, well, more titles, and text. This text can include a link, a formula, or an image. And how do you do that? If I double click, you can see the code. This is known as the markdown syntax. For example, to do a title, you put one hashtag. For a subtitle, you put 2, and so on. To put a link, you put the text that you want in blue in square brackets, and then between parentheses, you put the link. For formulas, Markdown accept LaTeX notation, so you can write formulas like this one. This one in particular is the Fourier transform, and also accepts HTML, so you can include images, for example, here. So if we run this cell, it produces this. So it's a very easy way to write something without having much trouble with the formatting. You just write this, and then it's parsed to very beautiful text and image or formula. The second type is the code cell. For example, here I have a we will learn about this, but this is a code that prints the numbers between 0 and 9. And for example, the main idea of programming is that I can do things like this, and now it's printing the numbers between 0 and 14. So you let the tedious tasks to the computer, and you start doing them less tedious tasks like thinking or making an hypothesis, because that's more fun, obviously, than doing the same thing over and over again. Another type of cell that is also a code cell is not necessarily intrinsically different, but in Jupyter Notebooks you can also import this thing here and do interactive cells. Here, for example, I did a program that plots a sine wave, and with this slider I can change the frequency. Here you can see that I can move it and change the frequency, and when I put it negative or 0, it also works. Okay, so this is the introduction. And how do you open this type of notebooks? You can open it with this command. Sorry, let me put this like that. Jupyter Notebook, this will be in the terminal window, that black window or white window that you can open to put comments in Mac or Linux or Windows. You can type Jupyter Notebook and the name of the notebook, and it will open the file in a browser. If you don't want to do that in the terminal every time, you can, for example, download the software Interact that allows you to just double click the files and they open. I think it's a little bit easier if you don't want to waste time or do anything very particular that the Interact could not handle. The activity 0 that you will do after the TA, it will be to install Anaconda and start playing with it, but this is for later. Now I'll be starting the second tutorial, or the first one actually. Do you have any doubts or a comment about what I just said? I mean,
No,
what?
nothing. It's very
Very easy, right?
Yeah, no, o sea, understand.
So we only download Anaconda, not Python, right?
Anaconda is
Yeah.
a way to have Python and a lot of packages very easily.
Okay. So, okay.
By installing Anaconda, you are also installing Python. As you can see, an Anaconda is a bigger Python, so it includes more things.
Okay, thanks.
Now you're seeing the second tutorial. Okay, so for this tutorial, go to the Canvas web page, okay? And you'll go here, and you can see the tutorials and click the first tutorial, okay? By clicking it, you'll access the exact same notebook that I'm using when it loads, obviously.
Sorry, Carlos.
Here. Yes?
How do you achieve to appear the code of the text? For example, in the part of title, subtitle, subtitle, how do you
if you want, for example, in this slide, I put something that is code.
For example?
I forgot to say it, but you can put here in between three this character at the start, at the end, and you can specify the programming language here if you want to have a syntax highlight. I'll be showing a better example in the second or the first tutorial.
Perfect.
But when you have something like that, you just run it and then you have code. But inside the text, this is not executable.
Okay.
Okay, as I was saying, if you open the link inside the Canvas web page, you'll have this collaboration notebook. Yes?
Where's the link?
The link is here. In página de inicio, tutorials, tutorial 1, and you press that.
Thanks.
When you press it, you'll be redirected to this page. This is the exact same notebook that I'm using, and you'll be doing your activities here. But if you want, you can also see at the same time what I'm showing in a slideshow if you want. So this is the same, but I put the notebook as a slideshow, so it's easier for you to see. Okay, so let's start with the tutorial 1. When we have an activity or something, I'll be stopping the tutorial, and you'll have a time period to make the activity, okay? The first thing we need to know to use any programming language is to know what a variable is, because that's the main advantage that a programming language has versus doing a thing by hand, that you can set a variable with the respective value and then operate on that variable, and you don't need to start annotating the value over and over again. So a variable is a name that we put to something, for example, a value, a matrix, whatever. And here I show an example. For example, the name of my variable is x, and I want to set it to the integer 2. I just put x equals to 2. If I want to set y to 5.0, that's different because this is an integer type. This is a floating point type. I will not go in further detail about the data types, but it's important that you know that the variables have a type. And I can also set, for example, xy to be hey, that is a string or text. If you want to see, we can execute the cell, and then print will show the value of the variables. Here I'm showing the result of adding x and y, that obviously is 7, and here I'm showing only the string hey. So if you put print x plus y, comma, xy, it will print 7 and a space because of the comma, and then xy. Like that. You also have another types of variable, but I'll be explaining them later. You can also, in Python 3, do very convenient things like this. For example, if you have a variable that two variables that have, for example, the same value, you can set them, instead of doing x equal to 1, y equal to 1, you can do the same by doing x equals to y equals to 1. This is exactly the same that the thing here. Another thing that I forgot to mention is that when you put a hashtag symbol or here and the thing goes blue, that's because this is considered as a comment and this will not execute. I can put whatever I want, and is commonly used to start saying what my code is doing and or start documenting the code, so you can later see the code and understand what you were doing. Okay, so if, for example, do this assignment of multiple variables, we can see that the print statement shows that x is equal to 1 and y is equal to 1. If we later do y equals to 2, we are not modifying x, so if we print them again, you will see that y is equal to 2, but x remains as 1. Oh, another thing that I forgot to mention is that if you want to, for example, assign two variables but as different in the same line, you can do like that. This is the same as x equal to 1 and another line y equals to 2, but you can do it in the same line. It's a more efficient way to do it, and sometimes it's more organized. Another thing that we can do between variables is to do arithmetic operations. The basic arithmetic operations are listed here. One is the addition, subtraction, division. This is different in Python 3 because in Python 2 the division was an integer division. So for example, if you divided 1 and 2, it will give 0. In Python 3 the division is a division that casts the variables to float. Therefore, if you divide 1 by 2, it will give 0.5 instead of 0. And to do the integer division, you do it with 2 slashes. Another thing that is very used in programming is the modulus operator, multiplication, and the power. That is different in another program to other programming languages, because here instead of the little hat, you use 2 multiplication signs. So for example, if you want to raise 2 to the power of 2, you'll do 2 double asterisk 2. This is an example. If you have 2 variables or 2 numbers, if you add them, just do it like that. Here, if you divide 1 divided by 2, in Python 3 it will give 0.5, but in Python 2 it will give 0. We are using Python 3, by the way. And here is the remainder or modulus operator, remainder of the division. This is equal to the remainder of 15 divided by 10. Another thing that we can do between variables or in general is to have relational operators. For example, we can see if 2 variables are the same by doing double equal sign. We can see if they are not the same by doing an exclamation symbol before. If they are numbers, we can see if, for example, if one is less than the other, greater than the other, less or equal, greater or equal. For example, here we have a variable x equals to 3, and we want to see if x is not equal to 1. And we run this cell, and as you can see, that's true because set is not the same as 1. If we assigned set to 1, this will give now a false, because set is equal to 1. Therefore, when we ask the question set is not equal to 1, that's a false statement. This thing here, it's what it's called a Boolean operator or Boolean variable. Basically, something that it will give a value of true or false, and we will use them in the control flow that I will explain later. Okay, so you can also do more logical operations with these Boolean numbers or Boolean variables. For example, this thing here, set less or equal to 1, it will give a Boolean number, a Boolean variable, sorry. And this set greater to 0 will give also a Boolean, true or false. This will also be true or false. And we want to see if this or this is true. For example, let's say set is equal to 1. Therefore, set is less or equal to 1, and also is greater than 0. Therefore, this will be true. This will be true. And when we have true or true, we can see that obviously that's true, because we want any of those to be true. Here we have the tables with all the possible combinations. For example, if we have the first thing true and the other thing true, it will give true when it's an AND. This is our case. If we have any of those being false, it will give false. And obviously, if both are false, it will be false. And this is the table for the OR operator. So this has as an input, for example, 2 booleans that could be described as this, and it will result to another boolean. We'll talk a little bit about built-in functions now. I commented that you have different types of variable. For example, one is the integer, and another type of variable is the string. You can convert between, for example, an integer and a string with these functions. For example, when you use the int function, if you put whatever inside, it will try to convert it to an integer. If you put the string function, use the string function and put a variable inside, it will try to convert it to a string. For example, if you do int of 7.7, that obviously will give 7. But if you have int of quotations 7, that will give 7 as well. It will convert the string to an integer type. So you can, for example, do addition here. This will be 7 plus 2, 9. And if we want to convert the string to, if we want to convert an integer to a string, we can also do it like that. You see that now it has quotation marks, so that means that it's a string. Okay. There are also another functions. You can see them later, but you can also convert to binary, to a character, to a floating point number. You have all the combinations possible. Another very handy function is to use the round function when we have numbers with a lot of decimals. If we use round of for example, this number, it will round it to the nearest integer. The nearest integer is 6. But for example, if we put comma 2, as you can see here, there were no commas here. But here you have two inputs to the function, and the second input of the function is the amount of decimal places. So for example, here I rounded this number to just 2 decimal places. So we will give 4.56. You can also define complex numbers with the complex function by a string, but there's another way. You can also do it like this with the j. This is the same number, as you can see. And when you do the absolute value of a complex number, it will give the modulus, the complex modulus of the number. That's why when we put the absolute value here, it gives us the same answer as the real part plus the imaginary part, and the square of both added and the square root. Okay, so I think, oh no. Yeah, okay, so I'll have 2 more cells and we have our first activity, so be prepared. Another function that I want to talk about is the range function, in which you can call it as with 1 argument, 2 arguments, or 3 arguments. If you call it just by 1 argument, for example this way, the argument is 4, range of 4, it will give me a list or a container of numbers with the numbers between 0 and 4, not including the 4. That's very important. The range function does not include the last number. If we put 2 arguments, by default, it will include the first one, but not the last one. Here, a is equal to 2, and b is equal to 13. So this is range of 2, 14. And as you can see here, the result does not include 14. And if we put a third argument, we'll be specifying the jumps until the number. Here, the jumps between the numbers is 1. 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1. Here also have jumps between the numbers of 1. But for example, if you put dx equals to 3, it will start at 2, but it will jump 3 numbers. So that's why you have 2 here, 5, 8, and until 14, without including it. That's why you don't see a 14 here. Another thing that's very handy is to have an input function with a question. For example, here I'm asking of x, that could be whatever. So if I execute this cell, it will ask me x, or what is your favorite number? Whoops. Sorry. I need to stop the execution of the cell because I didn't respond, so it got mad. Okay, here. What's your favorite number? And my favorite number is 7, so yeah, I answer, and the variable ABC now is 7. If I execute this, we can see that the type of variable of ABC is a string. If I print the variable is 7, so we can convert the string ABC to an integer by doing the int function, and then ABC int is equal to the number 7. So that's a way you can ask the user of his favorite number. Okay, now we have the first activity. I'll be asking 2 things. The notation here is that when the title is red, it will be something for more advanced students, or engineers, for example, that have that are more knowledgeable in math and programming, so they don't get bored. And this is the activity. We will take 15 minutes. I ask 2 questions. One is the favorite number, something similar to the first to the previous slide, and also something about even numbers. So as you can see in your Google Colab, by doing File, open in Playground mode. So for example, here, if I open the Google Colab in Playground mode, you're gonna start modifying the notebook. And here, if you click at the first activity, I put cells in which you can do the activity. So try to do the activity here, and if you have any doubt, start talking to me. But now we have a pause of 10-15 minutes, and we'll resume after that. Everything's clear about what I've said? Or
Yes.
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 Yes, yes.
okay, yes,
Can you hear me?
yes.
Yeah. Would you repeat the definition of a string?
Yes, a string is a, let's see if we can do it here. A string is basically a text, and a string is defined when it's in between quotation marks. For example, I'll add another cell here. Here. So for example, if I put hola is the name of my variable, and I want the string to be as is in between quotation marks, it will be a string type, basically text. It can be defined with double quotations, single quotation marks, or with triple quotation marks. Whoops. So this is the same as this, and it's the same as this. All of these 3 cases define a string. Is it more clear?
But the string could be eventually transformed into a factor or into
A numbers, yes. For example, if I have the string hola, it doesn't make sense to try to transform it to a number. But for example, if I have this, I can transform it to a number. This is very useful when you're reading a file, and the file is full of numbers, but it will read the file as many strings, and then you can convert those strings to numbers and save them to your programming language and do operations with them.
I mean, what is the utility?
The utility of the string?
Utility of having things like strings if you can have them as character factors or another thing.
There are things that can only be defined as strings. For example, a file name. For example, this. If you want to read or write a file name that could only be assigned by a string, it will not make sense to put a number. So you can also specify, for example, a fuller or more complex path, like documents hola.jpg. That, for example, is one use of the strings that I can think of right now. So, for example, here your variable that contains the file name is file name, and then you can do an operation with that. You can read, for example, the file name. Is it more clear now, or?
Yeah, see? Okay.
Yeah.
Thank you.
Just a reminder that you can share your screen in Zoom. So if you have a problem with the programming or something like that, you can share your screen and I can see it. Everyone is able to modify the notebook with the playground mode?
Yes.
Yes? Nice. So start coding in the cells that I put for the activity. Okay, has someone already done the favorite number activity?
Yes.
We are starting very basic, that's why the activity is easy for some of you, but the other ones will not be that easy. The things in red, if someone wasn't in the conference before, meant that is a little bit more difficult and is for more advanced users. So if you have time, so you don't get bored, start doing the red parts.
Are you gonna show how to do it?
Yes, after the 15 minutes, I'll show the solutions.
Okay, thank you.
Carlos,
Yes.
when you ask for the argument of the complex number, are you asking for
For the
basically
face.
the components?
For the face. The
Oh,
arcotangent of the imaginary part divided the real part.
okay. Do we need a library to use those
Yes.
NumPy?
Not necessarily, but for the inverse tangent, you need to import something from the math module.
Oh, yeah. How do you...
Carlos?
Yes.
Yeah.
Run modulus of a complex number. The program start running, but very, very, very slowly. Is there a reason for that, or my computer is very bad?
Can you show me the what are you doing?
I can share screen.
Yes.
Screen. When I run, just like that, and I print the absolute number.
I'm
That when I run it,
I'm not
start
seeing
running
your
smoothly
screen.
the first time, the second time run smoothly, but when I run it again in another cell,
Come in.
okay,
Your screen isn't showing.
what?
Now I can see it.
No es okay, no me understand. ¿Ahora lo ven? No, no es. Okay, I have very much trouble showing the screen. I don't know where.
I'm seeing your screen. Yes.
You can see it?
Yes.
But it's not the. I don't know what I'm sharing with this. And you see this? When I run that cell the first time, it take like 1 or 2 minutes. When I run it again, it runs smoothly. Is there a reason for that, or?
I'm not quite sure. It could possibly be because it's an internet online tool, and you here have a RAM and a disk that you have assigned. As you can see at the top right, it could probably that's too small, and sometimes it's not your computer, it's the cloud computer that could be slow.
Okay. Okay. I start thinking that I doing something wrong. Thank you.
Okay, how are we doing? Everyone finished the the first two activities?
Not quite. Well.
Okay, we'll continue. If you didn't finish, don't worry. I'll show the solution of the first one. Here. Okay, so the favorite number is asking to ask the user for her or his favorite number, and then display the number multiplied by 13, divided add 1/2, and then divide by 3. That means that we'll use our input function. Here we put a string asking for the favorite number. What is your favorite number?
Can you show the screen?
Oh, sorry, I misclicked the interface. Okay, now I'm showing it. This is the favorite number. We put the x equals to input, then the string of what I'm asking. What is your favorite number? And we want to show or return the number. How was it? The number multiplied by 13. So 13 and an asterisk to multiply. Then you add 1/2, and then with a parenthesis, you I don't multiply by 3 or divide. Divide by 3. So, for example, we have, if we execute, what's my favorite number? 7. I enter. Oh, sorry. Oh, it's a string. Sorry. So x is a string. So we need to convert x to an int. That's what you need to do here. We put the int function, and then you execute 7, and you have the number. 7 times 13, blah blah blah, and it should give this. Okay, that's the first activity. The second one was display the even numbers from 2 until 13. What we need to do is 2 and 2. This is so I don't forget. We need to use the range function. So basically we have x equals to range from 2 until 13, and as we want to show the even numbers, we'll skip 2 numbers. And let me see if we can print x, or just put x. Oh, sorry. Print x. I need to convert it to a list. Range is a special object, so it's not storing all the values to save some memory space. So to convert the list to an actual list, you need to use the list function. So here we have the even numbers between 2 and 13. These two.
Is range like a sort of tuple? What is it?
Range is a range object. It's something special done to save memory. So range is not anything until it's being called. For example, in a for loop, when you start seeing the elements, that's when range start giving the values. They are not stored anywhere. That's why we need to convert it to a list. Another way is to do this, but I haven't talked to on the fors, but sorry, for in range x print x print I, sorry, here. So in the for loop, we are not converting x to a list, but in each iteration we are acquiring one element of the range. That's why we can print it, but the x variable is, if we put type x, is a range object. So range is a special type of object in Python. Okay. And this is more advanced. Okay, for the complex numbers, you can solve it in home. I will not be explaining the solution. But one thing I want to talk about is about the triangular inequality, because this will be very useful in the course. When we have a complex number, for example, z is equal to a plus b I, that could be represented as a vector in the real imaginary plane, in which the real part is a and the imaginary part is b. The modulus of this complex number is the length of this arrow, and the argument is this angle. That's why the argument is equal to the arcotangent of the imaginary part divided by the real part, and that's why the modulus is equal to this expression here. If we have two complex numbers, for example z and w, the triangular inequality is derived from the multiplication of the addition of both. And let me add a page here so I can go to another page, and we start with this set and we add w and multiply by the complex conjugate. Okay, the complex conjugate of a complex number is, for example, if we had our set equal to 1 plus bi, the complex conjugate of that number is equal to a minus bi, or in our previous drawing is the reflection of the complex number when we do it with the real axis. So the conjugate operation reflects with this axis. And something very peculiar is that when you multiply a complex number with its complex conjugate, you have the modulus squared. So this is equal to the modulus squared. But if we just use the distribution of the conjugate, we can have z conjugate, w conjugate, z and that, and we do the operation, it will result the complex modulus of z plus the modulus of w, and then we'll have z W plus W set. Well, it doesn't matter if we put them like this. But the thing is that this is a complex number. For example, we can call it your favorite number, D. I don't, whatever, it doesn't matter. This could be a complex number, and this is the complex conjugate. As we are adding the complex conjugate with its just the complex number, we obtain 2 times the real part of this number. That's why we have the following inequality. So this is the equality, but when we have the inequality, we remove the real part. So this is what it's called the triangular inequality. Did you get why the inequality is like this?
Why is it bigger? Why is it lesser than?
Oh, sorry, I made a mistake. Thank you. There.
Okay, then again, how do we know that the real part is a positive number?
The real part.
Do we know?
Let me see. The real part of this multiplication is always a real number, because if you see it in a plot, for example, let's say Z is this complex number and W is this complex number. What you're saying here basically is that let me put the correct names, Z and W. What you're saying with the triangular inequality is that this length here will always be greater than the addition of the other sides of the triangle. That's why it's always satisfied. You can see that when this is maximum, when you maximize the expression, the dot product will result in the dot product will result in the complex conjugate of this multiplied by this one, but that's like the inner product, or the projection of one into another.
Yes, my only question is does that that real number have to be positive? Couldn't it be negative, or do you have to use like the absolute value of that multiplication?
Let me think. So let's where is it? Here. So we have the number Z and W. When you're saying here, now this could also be positive. Sorry, negative. There's no limitation in that. But if you can see, if this is negative, the inequality still holds, because this will be greater anyway. You see? When the real part is negative, this will still holds. If it's positive, that's why we removed that part. Hello?
Yeah, okay.
Okay, let's continue. We have half an hour, so we'll skip one activity. You'll do it later by yourself. Okay, so let's talk about the print statements. Here we have something that we already used using the print of a string, but something that is a little bit more advanced is to put, for example, a comma to put any variable here. This variable could be an int, and it will be parsed to a string. So for example, if you have hello and comma 2, you'll print hello and a space and a 2. It will be parsed to a string. Here, when you have an addition sign, you can concatenate the strings. For example, if this is how are you, a string saying how are you, and you put a plus sign, it will concatenate how are you without a space. So you'll get hello without a space and how are you. And the last way to use the print function that I think is the most useful one is to do a formatted string. Here, when you have, for example, s with a % sign, it will mean that this variable here will be parsed as a string and added to the string itself. For example, if this variable is 2, you will say hello space, because there's a space here, and then replace all this by 2. Oops, sorry. And you can change it with a lot of different types that I think I explained later. But basically, here it says that a string can be defined by single, double, and triple quotation marks. And here I show basically the same I already said, that when you use a plus sign, it will concatenate the first string with the second one. And when you use the % sign, you can do a formatting of the output. Oh, sorry, I missed the parenthesis here. So for example, here, if you have a string 1 or whatever, it could be 2 or any variable, and you print it, it will say hello, this space, and the variable here. If you do %d, it will put it as an integer. If we do %f, it will put it as a float number, and if we do %e, it will put it as an exponential or scientific notation. So for example, if we put f, instead of 2, it will print 2.0000. If we put e, we'll put it like 2, and then 10 to the 0. Or for example, 20 is 2 times 10 to the first power. Here I have an example of the same, but with the number 18. Here is printed as an integer, as a float, and in scientific notation. Now, when referring to multiple variables, parentheses can be used. For example, if I have a string 1 and 2, being world and exclamation mark, I can fill the hello, world, and exclamation mark by doing this. So I just repeat the %s to parse it as a string, space, I put 2 spaces. Now you have only 1 space, %s, and it will replace the first one with string 1 and the second one with string 2. So here we have hello world. Okay, this is an advanced topic. As you can tell, the precision in which the float numbers is printed is by default 6. That's why we only have 6 digits here, but you can also change it. You can change it by doing something like this. For example, here, if you put 0.5, what you are trying to do is changing the precision width. Whoops, sorry. And before the dot, you can put the field width. That means how many characters you are trying to print. For example, if you don't put anything, it will print normally, but if you, for example, put 6, it will print with 6 characters. If you put 7, let me see. No, it doesn't change it, but now in this particular case, it's not changing. But yeah, you can define the precision with this syntax. And also, a very useful example is when you have, for example, 2 numbers and you want to write it to a file, but the file always accepts the number, for example, with a space in case of if you have a positive number, but if it's negative, you have a negative sign. To do that, you put a space after the percentage. So you can see this. Okay, so I'll start with the control flow statements. This is the most useful thing in a programming language, probably. The first one is the if statement. The if statement is something that it will be executed, for example, algorithm, only if the condition here is satisfied. In reality, you don't need to put a condition, you just need to put a Boolean number. For example, x greater than 10 is a Boolean number, or a true or a false. And if this is satisfied, or the expression is equal to true, it will enter to the algorithm, in this case, print hello. So, for example, here, I have x equals to 12. That is obviously greater than 10, and when I execute, it will enter and print hello. If this is 8, it will not enter to the algorithm and will do nothing, basically. When you have another case, when you don't want the statement to be true, the negation, you can put an else statement. So for example, if the condition is satisfied, you'll do this algorithm, but if not, you'll do this one. For example, here, x is equal to 12, so it's greater than 10, and it will print hello. Sorry, print with the parentheses. Here, it will print hello, but if it's less than 10, for example 9, it will print world. And if you have more than 2 conditions, you can use an elif statement. For example, when the first condition is satisfied, will be this. If other condition will be satisfied, is this. And if you don't have any other possible case, it will do the last one. You, for example, have here an if statement that compares if x is greater than y, another one that compares if it's less than y, and another one that is if any of those didn't satisfy, that in this case is that if x is equal to y. For example, here x is 10, y is 12. If I execute the program, sorry, then the parentheses of the print functions. Like this. Some parts are missing the parentheses because we're reading in Python 2. So now, as y is greater than x, it prints exactly that. If it's less than x, it will change. And if the same, it prints that they are the same. Yeah, okay. So another thing is the for statement that you have in Python. That is to do the same thing or multiple things over and over again. That's why they are called loops. So basically you write this as for a variable inside something, execute this algorithm. An example, you have, for example, this range 5 that, as we already know, it will create a collection of numbers 0, 1, 2, 3, 4, and does not include the 5, and it will iterate in each element of this list, starting from 0, printing 0, then 1, printing 1 until 4. Okay, so this is advanced, a very good way to do for loops in some scenarios that you don't need them, actually, is to do a list comprehension. And this is basically a way to replace a for loop. And this, oh, I don't have the example. Okay, so I'll make the example here. Basically, there's a way to do it with a for loop to create a list. For example, here you have the range between 1 and 11. That means that starts at 1 and finishes at 10, and you multiply those numbers by 27 and you have the result. But another way to do it is just writing this 27 times I for I in range that. Printing res. Sorry. So the first algorithm does exactly the same that this line, but this is a more compact way to writing the same. I prefer this for some for loops that are not necessary. Oh, I had it here. Okay, so again, I just can write 27 times 4, and that's the same. So I don't need it here. I'll delete this line. Okay, another thing is to define functions. The notation for functions is def function name, the arguments. This dots is just to put a lot of arguments. This is not an actual notation. If, for example, it has 3 arguments, it would be like this. Okay. But this part is very relevant because the document string is a way to document your function. So if in the future you don't remember what it does, you can put what it does here exactly, and you can then ask for help, and it will tell you what your function does. After that, you can put what the function does with the arguments, and then return a value or not. You can return a number, for example, if you want your function to give you a number, but your function could also just do something, and that's it. That's called a void function. Here, for example, I'm defining a function called first function with parameter n, and what it does is just print the first n numbers starting from 0. For example, here. As you can see, if I don't remember what it does, I'm screwed. That's why I can put a docstring here. So this function prints the first n numbers starting from 0. So now, if I have my function and I press Shift Tab, you can see here that it will tell me that the docstring is this function prints the first n numbers starting from 0. So I can know what it does. And I can put more text. And if I ask for help, it will say all the string I put there. That's very handy. As I said, you can also return a number. For example, here I have a function named times that just multiplies x and y, and it returns the number of the multiplication. So for example, 1 times 2 is equal to 2. Another very handy thing is the lambda functions. The lambda functions are one-liners, the same as the list comprehension, and basically you can define a very simple function in just one line by this notation: lambda of x. That means a function of variable x defined as the operation x times x, and that's my function named set. So set of 8, what it does is 8 times 8. That is 64. Okay, now we have the activity. Let me see. Okay, so the diamond part we'll skip. This activity, you can do it at home. It's very good to start programming. Also the diamond activity. This is not that easy, as you can expect. And I'll talk about the numerical Python and packages in general, because Python is a programming language with a lot of potential in its packages. And that means that you can import a package, for example, that does statistics, another one that does integrals, another that does graphs or plots, and that's not defined in the built-in functions of Python, and you need to import them to start functioning. And the notation is, if you do it without a prefix, is to do from the package import the functions, separate by a comma. For example, you have the package numpy, you do from numpy import zeros and line space. This will only import these two functions, and it will you can call them by just using the name of the functions, like that. See, you can create an array of 2 zeros. Another way of calling the packages is with a prefix. For example, import package as the given prefix. For example, import numpy as np, and then to use the zero or zeros function, you do np dot zeros, and you have exactly the same. An advantage of using the previous method is that, well, the functions are easier to call. You just put that, and also that is faster because you don't need to import all the packages. But another advantage of this method is that you, for example, if you don't know the name of a package, you can use np and then use tab, and you have a lot of functions here, and you can just search them. For example, here I have the arctan function, and I can do the activity one. So we were talking about the numpy package. It's well, the name numpy stands for numerical Python, and it defines a very important thing that is called an array. As we already talked about the list of numbers, Python has a list of numbers, but it doesn't have a fast way of operating with lists. So, for example, you do something with a list in Python, the built-in list, it will be very slow in comparison to the numpy arrays. That's why I didn't even taught the built-in lists. But this is basically the same as the list, as a list, but it's an object. All the numpy arrays are objects. So for example, if I want to create a list from 0 to 2, numbers from 0 to 2, and just 9 numbers evenly distributed in that interval, you can use the line space function between 0 and 2, but here, instead of defining the interval, you define the number of points. So this is very useful in a lot of scenarios. Here you can execute and use the line space function, and we'll create an array starting from 0, and then you have an interval of 0.25 until they are 9 numbers, and that's it. Another way is creating an array with zeros. For example, here, the zeros function, if you put 9, it will create an array with 9 zeros. But in general, also, there's a built-in function in Python called length, or len, that you can use to know how many elements it has the numpy array. For example, in the previous cell, I defined x as 9 zeros, and here, if I try to evaluate the length of x, I have 9. Okay, as I was saying, you can also define the numpy arrays just by using the array function and putting a list of the numbers you want to put in the array. Here I defined a numpy array with the numbers 0, 1, and 2. How to obtain the elements of that array, or to modify one element of the array? With the indexing that is used that you use with square brackets. So for example, we have an array 0, 1, and 2, and we want to get the last number 2. We start from 0, 0, 1, 2. Let me change this number so it's not confusing. So what it means here by indexing the number 2, it will start by 0, 0, 1, and 2, and you will get the number in the second position starting from 0. You can also start from the end with negative indexes. So for example, -1 will start from the end. That's 5 also. This is to get the values of the certain positions, but to set the values of certain positions, you put x square bracket 2. For example, here, the position that you have the value 5, you can modify it by changing here. So now I'm changing x, the position 2, to a value of 8. And I can see that the last number is now 8 instead of 5. Something very important when you use an array is that it's an object, and therefore you are, when you do an equal or an assignment of the object, you are assigning the direction of in memory and not the values of the array. That means that, for example, here I had the same x as before and assign a variable y to x. I can see that my y is 348 as before, but if I change something in y, it will also change in x, because when you do this, you are assigning the object and not its values. Okay, so this is very important. I had problems with this when I was starting, and I was like one whole day trying to figure out the error, and this was the error. So how to do it properly? You need to do this. Y equals to x, copy that. So now, as you can see, if you modify y, x will not change. Well, here is 10 because it was assigned as 10 before, but let me show you. If it's 0, it will stay at 10. Okay, another very useful thing is slicing. When you slice an array, you instead of just putting one number, you put two numbers separated by a colon, I think it's called. And when you do this, for example, you have a line space or an array starting from 11 to 16. If you took 0 to 5, it will take the first 5 numbers, but starting by the first element. You can see that the first in reality the first element is the index 0. So the index 1 will be 12, and then until 5 you'll get here until 15. Why you didn't get 16? Because in Python, as the same as the range function, when you put the end, it's not included. So the first index is inclusive, but the last index is exclusive. It's not included. Okay, you can do that the same in 2 dimensions to do matrix calculations, but I'm not sure if I'm using it. Yeah, I need to teach this. So to use more than 1 dimension, for example, to do matrices, you can create a matrix. Instead of putting just one number, you can put a tuple, or basically 2 numbers in a parenthesis, and this will generate a matrix of 3 elements down and 3 elements to the right, or whatever you want to say. So here I'm assigning I to a matrix of 3 by 3 zeros, and here I'm assigning the diagonal terms by 1 to create the identity matrix. So this is a matrix now, and I can also create a vector 1, 2, 3, and use the dot product to multiply the matrix I with the vector x. And as you know, when you do the identity operator, you get the same vector. If you are more used, okay, so NumPy, this is very important. By default, do the operations element-wise. For example, if you have an NumPy array 1, 2, 3, and another one that is 3, 5, 8, when you multiply them, it will not do a matrix operation like in MATLAB. It will do a point-wise operation. That means that you multiply this one with this one with this another one, and so on. If you are more used to the MATLAB way, you can define the times operation as the matrix vector product by defining matrices. The only thing that this means is that when you create the matrix, then you change the type of object I to a matrix, and as well with the vectors, they are also a matrix. And then you can do your usual operations. By default, when you use the matrix function to a vector, it will be a row vector, so that's why we need to do the transpose. And when you multiply, as same as before, the identity matrix with the vector, it will give you a matrix with the corresponding numbers 1, 2, and 3. Okay, so I had some activities here, but I think they are there's not enough time. You can do them at home, but what I wanted to see, because it's very important, and you will probably see it in the homework, the first homework, is the Gram-Schmidt process. There is an application of this. So the Gram-Schmidt process is what you're looking here. Basically, you start with a set of vectors that are not orthonormal. That means that could be in any angle. It doesn't have to be 90 degrees between them. And starting from those vectors, you start getting a orthonormal set of vectors, V, by doing the Gram-Schmidt process. What this process is is what is shown here. You start removing the contribution of the other vectors to my first vector. Then I start doing that with all the vectors. I basically remove the non-orthogonal part between them, and finally you get 3 orthogonal vectors. The algorithm is something like this. This operation here is defined as the projection of the vector v to u. In our little drawing, or let me use the pencil here to show you. I'll change the window here. Okay, so what's the projection? The projection is, for example, if I have this vector u, and this one is b, if I do a line here with 90 degrees, this vector here is the dot product between u and b. That's the length, but the direction is sorry. Oh, sorry, and the direction is u. This pink vector has direction u, and you don't want to add the length of this vector u, so you divide by the length. The dot product between a vector and itself is the norm of the vector squared. So by doing this projection operation, you basically get, for example, z is equal to the projection respect to u of b. Okay, so this operation is a key part of the Gram-Schmidt procedure, and as I already said, this tries to remove the parallel part of the vector with respect to the others when in the Gram-Schmidt procedure. So here, the first vector of my orthogonal basis, you can just pick whichever vector of your set you want, for example the first one, and then the second vector, you need to remove the contribution of the first one. That's why you project b2 to u1. That's the parallel part of b2 with respect to u1, and you remove it, so then you have a orthogonal vector u2 with respect to u1. Then, to have your third vector, you have b3, that is your third vector, and you remove the parallel component of b3 with respect to u1, and also with respect to u2. And basically you start doing the same to every vector, and at the end you get a set of vectors that are orthogonal. And also, if you divide by the modulus here, what you're doing is to get an orthonormal basis. That means that the norm of each vector is equal to 1. What I want you to do now, if you can, you can tell me now, because I think this is important for the homework, is trying to define a function that gives you a set of orthonormal vectors u1 until 3 when you put the inputs v1, v2, and v3. Okay, so many of you had another class. So the rest, do you want to work in this, or we leave it at this point? Do you want to try to solve this? Because it will be important in the homework.
I think it could be a good idea. Eventually, you could, I don't know, next time we have one of these, what do you call it?
Tutorials? Okay.
Tutorials. Yeah. So next time you could give us like the answers or show us some of the, for us to like to do this by ourselves and see if we get the right answers. I think.
Well, the solutions, I can upload the notebook with the solutions, but
okay.
I think it's best if you try to do it yourself.
Right.
The next tutorial, I'll give the solution of these questions. Okay, if you want to see them. But I think in particular this last one, I need to explain it again because it's important for the homework. But instead of vectors, you'll do it with the functions. You haven't seen the dot product between functions yet, right?
No, yeah.
Okay, yeah. But basically, this procedure is important because of that. And I also thought that we will advance more like quicker, but it was my mistake. Okay, so we'll leave it like this. Everything will be in YouTube anyway. I'll upload a link with everything we already talked if someone wants to see it. And we'll see each other, or not see each other, in the next tutorial. I tried to hear, but in building construction. Okay, so Javiera couldn't hear, but don't worry. What I said, I'm not sure if you are hearing now, but what I said is that I will be uploading what we did now to YouTube. Actually, it's already uploaded, and I will post the link.
Yeah, Carlos, can I ask another question that was from before?
Yes.
Last thing. Is that when we were talking of complex numbers, when you put that into Python, and
yes,
and it saves it as a complex type of number. How do I like separate the real part from the imaginary part so I can work with them separately?
Oh,
because I couldn't get the phase without like I couldn't separate the two numbers to get like the arctan of one over the other.
Let me explain that now. Here. So if you have a complex number, for example, z is equal to 2 plus or 3 plus 4j,
yeah,
then I'm not sure. Let me see. If you use the dot, you can do the conjugate, the imaginary part, and the real part. So for example, here set dot real is equal to the real part. Set dot imaginary is obviously the imaginary part. And you can do operations that way.
Okay, perfect.
Okay, So we'll see you in the next tutorial. Thank you all. Yeah.
Question?
Okay. Yeah. If you have more questions.
Pretty much with the Python tutorial is more that how do you make the notebook in Python a presentation, a slide?
That's a good question. Okay, so I'll stop the recording in YouTube, but we can continue